Here's an interesting project where I generate a spinning image or a spinning logo onto a digital oscilloscope. The signal is generated by an Arduino microprocessor, which then translates it to an analog signal through a digital to analog converter. So how do we get there? Here's a quick overview. So you've probably seen Lissajous figures in other videos. So those circular images are generated by mapping out two sine waves in XY mode and varying the frequency and phase between them. But what if you could control the input signal? Instead of using sine waves, I want to be able to generate my own waves so that I can make a specific image. First, we want to draw the image that you want to project onto the oscilloscope by hand on a grid. You can see here that I have a range of roughly 0 to 200 along the x-axis and 0 to 160 on the y-axis. Then I generate the same image into an Excel file by creating an XY coordinate and then having it charted to verify that my image looks just the way I drew it before. Those XY coordinates that I generated in Excel were then loaded into an Arduino array where I inserted all these points and then manipulated them to generate analog signals for both the X and Y axis to be output from the Arduino board. This is a schematic showing how the Arduino program generates a digital signal that's represented by each one of these digits here. This DG1 representing the least significant bit and DG8 here being the most significant bit. The output to the oscilloscope is connected here, which at this point becomes an analog signal. So this is a digital to analog converter, and it's known as an R2R ladder digital to analog converter because of the type of configuration where you have a resistor across the top here separating two resistors that are in line with each one of these digital outputs. The result is a conversion which gives you an analog signal that you can pick up at this point. And we need two of these, one for the x-axis and the other for the y-axis. So on the Arduino I'm using pins 0 through 7 for the x-axis and pins 8 through 13 on the y-axis. So here's the Arduino board connected to a proto board which contains all the resistors that we described for the digital to analog converter. And you can see that we have two probes on it, one connected to generate the signal from the x-axis and the other for the y-axis for the image. We can see the spinning image right there, but if we were to change this back to a normal YT mode, this is what the display would look like with both signals in the usual display format where the x-axis represents time and the y-axis represents amplitude. By switching to the XY mode, we get the desired image. I have a few images preloaded into my Arduino program, so let's step through a few of those just so you can see some of the possibilities. There's the American flag. A little shout out to the USC Viterbi School of Engineering. So this is an octagon with lines that are connected from each of the corners. It's a pretty neat image when it's spinning. Let me try to center that so you have a better view. And I think I have one more. This was generated on a different scale in Excel, so I'm going to adjust the volts per division to make better use of the size of the display. There, it looks like the diamond that's pulsating outward. This is my Excel table for the octagon image as I was designing it for the oscilloscope. Hope you enjoyed watching this project that shows you a clever way to generate an image onto an oscilloscope. Try to recreate some of these images or generate some of your own.